So today's topic is the minimization method using tabular method or Quinn-McCloskey. So in the previous lecture, we already discussed the one type of minimization technique, that is using the Carnot map. But the Carnot map is very much convenient method for minimizing the Boolean functions up to the 5 variables. Okay. So if the variables will be increased greater than 5, then there is a lot of problems occur in using the Carnot map. So then we'll go for the tabular method or the Quinn-McCloskey method. So the Quinn-McCloskey method is very much utilized for the greater than 5 variable Boolean functions. Okay. So the Quinn-McCloskey tabular method is a tabular method based on the concept of prime implicants. The prime implicants is nothing but a product or the sum. Product means for sub expression and sum is for the pos expression, which cannot be further reduced by combining with any other product or sum terms of the given Boolean function. So this is the last result. So we cannot simplify again after getting the prime implicants. Okay. Now the basic steps of the Quinn-McCloskey tabular method. First step is to arrange the given min terms which are in the sub expressions given in the Boolean expression in ascending order. Suppose one minute please. Suppose the function is summation of m, or suppose 0, 2, 3, etc. So then suppose this is f is equal to, I will give the example in the next slide. Now for the step 1, arrange the given min terms in an ascending order and make the groups based on the number of ones present in their binary presentation. Here in the example, 0, 2 and 3 are the min terms. Okay. So now, depending upon the number of ones in the binary representation of the min terms, we make the separate groups. Suppose this is group A1. A1 means single one is present, or then there is no one is present. So no one is present is, that is A0 group. So that is 0. Then the A1 group, that means the only one number of ones are present in the Boolean in the binary form of the min term. So suppose it's 2. Okay. So only 0, 1, 0. And this is the 3, that is 0, 1, 1. So there is a 3 group. First group is only one min term is there. Second group, the 2 is only 1 is there. The third group, the 2 ones is there. Okay. So 0, 2, 3, these min terms are in separate groups depending upon the presence of the number of ones in the binary form of the min term. And it should be in ascending order. So first 0, then 2, then 3. If there is any n number of min terms are there, then the n number of min terms will be written in the ascending order. So there will be at most n plus 1 number of groups if there are n Boolean variables in the Boolean function. Step 2, then compare the min terms present in the successive groups. So then suppose the group 0, there is 0 only present. Group 1, here the 2 is present. Group 2, there is 3 is present. So now first compare with group 0's every min element to the group 1's every element. Then group 1's every element to the group 3 every elements of the group 3. So these should be in successive groups. We cannot compare with 0 to 3 or 0 to 2, we only compare with the 0 to 1 group. Here, we only compare the mean terms present in the successive groups if there is a change in only one bit position. Only one bit position change, then take the pair of those two mean terms, place this symbol dash in the differ bit position, which is different. That bit position should be symbolized with a dash. Okay, and keep the remaining bits are the same. Step 3, repeat the step 2 again and again when the prime implicants will not become. Step 4, then formulate the prime implicants table. It consists of set of rows and columns. Prime implicants can be placed in row wise and the mean terms can be placed in column wise. I will give the example in the next slide. Place 1 or dash in the cells corresponding to the mean terms that are covered in each prime implicant. I consider the tick mark instead of 1 because there are so many books follows the tick marks, okay, instead of 1. So some books use the 1 and some books use the tick marks. So I follow the tick marks. Find the essential prime implicants by observing column. If the mean term is covered only by one prime implicant, then this is called the essential prime implicant. Okay. All the mean terms, suppose this is one mean term is covered by only one prime implicant, then it is called the essential prime implicant. Now, the last, reduce the prime implicant table by removing the row of the each essential prime implicant and the corresponding to the mean terms that are covered in that essential prime implicant. Step 5 for the reduced prime implicant table. If it is repeated, stop the process when the final Boolean expression will come. Now the example. This is very important. Please go through seriously. Suppose this is an example. Summation of m 2, 6, 8, 10, 11, 14 and 15. Now the step 1. These are the mean terms. Depending upon the number of ones in the binary form of the mean term, I make the group. Suppose there is no 0, so there is no 0 group. If there is 0, then we should write at GA0. Okay, so there is no 0, so we will start from GA1. GA1 means this is the column 1, so for this reason this is 1, A is written over here. Next the column 2 will come, then we will write GB. Some books use as index 1, index 2, index 3, index 4. You may use this, no problem. This is your choice. If it is group name should be written by your choice. As this is a group 1, you can write it group 1, group 2, group 3, group 4, or G1, G2, G3, G4, no problem. Clear? But when you will write one nomenclature, then hold the problem, you should write the same nomenclature. So that is the GA1. So depending upon the number of ones, that is only single one. Then 2 have the single one, 8 have the single one. So we write the two mean terms 2 and 8 in group 1A. Similarly, for 6 and 9 and 10, there is a 2 number of ones. 6 have the 2 number of ones, 9 have 2 number of ones, 10 have 2 number of ones. Then we will make a group for 6, 9 and 10 as group 2. For 3 number of ones, that is 11 and 14, and it is in ascending order. Okay. So this is 11, 14 and 15. Now 11 have the 3 number of ones, 14 have 3 number of ones, 15 have 3 number of ones. So this is the step 1 and step 2. Now the go for the step 2, that is the comparison. Okay. So comparison means the successive group elements comparison with respect to the 1 bit position change. Here I have written the following table shows the possible merging of min terms from the adjacent group. So we can compare only GA1 with GA2, GA2 with GA3, and GA3 with GA4. We cannot compare with GA1 to GA3 because these two groups are not successive. Successive groups min terms should be compared with respect to the 1 bit position change. If there is no used min terms are there, then that min terms should be treated as the prime implicants. This is very simple. Okay. So here the use 2 and 6. 2 and 6, there is a 1 bit position change. 2 and 6, this 0 and this 1. So at that point, we should put dash. Okay. As the step 2. As step 2. Dash. Okay. Place the symbol dash in the deferred bit position and keep the remaining bits at the same. So remaining bits 0, 1, 0 are the same, 0, 1, 0 are the same. The 1 bit position, deferred position should be placed as dash. For 2 to 6 already done. Then 2 to 10, every element of two groups should be compared. So 2 to 9. So 2 to 9, there is no 1 bit position change. Yeah, so that is 2 bit position change. 1, 1, 0, 1. So that is not 2 bit position change. So this is not 1 bit position change. So we cannot consider this. So then again 2 to 10. 2 to 10, 0, 0, 1, 0, 1, 0, 1, 0. So that is 1 bit position change is there. 1 and 0. So dash 0, 1, 0. So dash 0, 1, 0. Similarly for 2 to 2 is over. So now 8. 8 and 6. There is no 1 bit position change. Okay. So we cannot consider it. 8 and 10. There is 2 bit position change. So 8 and 9 only. So 8 and 9, there is only 1 bit position change. That is 1 and 0. Okay. So then we will write 1, 0, 0 dash. So 1, 0, 0 dash. Similarly for 8 and 10. 8 and 10, that is this position is changed only. So we can write 8 and 10. 8 and 10. So 1, 0 dash 0. So in this way, we can compare. So every element of the group 1A and group A2 are used. So we put the tick marks beside the min terms. Again for GA2 to GA3, every element should be compared with respect to the 1 bit position change. And we will get 4, 6, 14, 9, 11, 10, 11 and 10, 14. These are the 2 bit position, these are the 1 bit position change. Okay. Now for again G3 and G4. So G3 and G4, then we will get GB3, 11 and 15, 11 and 15 and 14 and 15. So 11 and 15, 14 and 15. So here we will make the step 2 and 3. So now go for the another comparison, GB1 with GB2 and GB2 with GB3. So GB until we will not compare, there is no provision for comparing the min terms as per the 1 bit position change. Till then, we should comparison repeatedly. So then GB1 and GB2, then we will get GC1. GC1 we will get this, and here the dash will be treated as the element, same element. So if there is 2, 6 and 6, 14, 2, 6 and 6, 14, there is no 1 bit position change. There is 2 bit position change, 0 dash and 1 dash. Okay. So for dash is here treated as 1 or 0. Clear? Very simply, you should consider the dash is an self element. So if there is a dash here, then this is the matched element. Suppose this is a dash, this is a dash, then at that position there is 2 matched. Okay, so this is dash 1 0, this is dash 1 0. So 1 bit position change only this. So 2 6 dash 1 0, yeah, 2 6 10 14, 2 6 10 14. Okay, so 2 6 10 14. Okay, now 2 6, there is no others options, 1 bit position change, there is no options are there, so then go for 2 10. 2 10 with compare with 6 14, the dash is here, no problem, 1 0 is here, 1 0 is here, no problem, only that position is changed, that position is changed. So 2 10 6 14, already the 2 6 10 14 are used, 2 6 10 14 are used, so we should not consider this because this is a redundant. Okay, all the min terms are already used, 2 6 10 14. If we go for this 6 14, then we already get it as 14 from this and 6 from this, so it is the 2 min terms are in redundant, so we cannot consider it. So again go for 8 9, 8 9 and then 6 14, there is no option. 8 9 9 11, there is no option. There is a tricks is here. Tricks means, suppose when you will compare every element of the two successive group, if there is a common element, then you should not compare it. Okay, then time will be reduced. Suppose if there is a 2 and 6, here is a 6 and 14, so you should not compare this because 6 is common here. Okay, if there is a 2 and 10, if there is a 10 and 11, then you should not compare it because 10 is common here. Clear? So then the time will be reduced. So from this technique, we will get 2 6 10 14 one element, 8 9 10 11 from one is the one element from the GB1 and GB2. Now for GB2 and GB3, we will get only 10 11 14 15, 10 11 and 14 15. So from here we will see that all the min terms are used. 2 6, no problem, 10 is used, no problem, 8 9 is already used, 8 10 is already used, 6 14 is already used, 6 and 14 is already used, 9 11 is already used, 9 and 11 is already used. Okay, so all the elements are used from the GB1 and GB2. Now for GB2 and GB3, we will get 10 11, so 10 11 is used, 14 15 is used, so 15 is used, 14 is used, and 11 is used, so 11 is used. Okay, so all the min terms are used in these two groups. Now for GC1 and GC2, there is no option for comparing 1 bit position change. So this is the last step where we will get there is no comparison should be made. Then the every min terms here as the prime implicant. So we can write the prime implicant is P, Q and R. So from here we will go to the prime implicants as P is denoted by Y Z bar. Q is denoted as W X bar. This is 1, this is 0. This is the swap expression. The example was the swap expression. So the Y, the 1 means the Y, 0 means the Z bar. Here this 1 means the W, X means 0 means the X bar. So Q defines as W X bar. P defines as Y Z bar and R defines as W Y. Clear? So here I am written P is equal to Y Z bar. This is the prime implicant. Q is defined by W X bar, and R is defined by W and Y. Now put these P, Q and R in the prime implicants table. Here we will go these three prime implicants. Now put in the prime implicants table. I already mentioned in the second slide that the mean terms are written over here in the row wise, that is the P, Q and R, and the mean terms are written over in the column wise. So 2, 6, 8, 9, 10, 11, 14 and 15, which are used in the Boolean expression, SOP expression. So now put the prime implicants here. So this is the P, this is the P, this is the Q, and this is the R. So P defines the 2, 6, this is P. P defines 2, 6, 10 and 14. So 2, 6, 10 and 14. They are selected by the tick mark. And this is the Q. Q means the 8, 9, 10, 11. So Q means the 8, 9, 10, 11. This is the R. 10, 11, 14, 15. So 10, 11, 14 and 15. Okay. So now here the table shows that there is the 2 is mentioned by or selected by only one ticks. 2 and 6. So 2 and 6 only covered by the P, not Q or not R. Clear? So to cover up the 2 and 6 mean terms, we should select the P as the essential prime implicant. So the P is selected by the essential prime implicant. One essential prime implicant. So then we just reduce the table and remove the prime implicants from the next essential prime implicant tables. So now for the go for the 8, 9, 10, 11, 14 and 15. So here by using P we will get 2 and 6 and 10 and 14. Automatic choice. So the rest amount of the mean terms are 8, 9, 10 and 15. 8, 9, 10 and 15 written in the essential prime implicant table. So then this is the only Q and this is the only R. So now select the Q and R. So Q is selected by 8, 9, 10, 11. 10 is already selected. So now the 8, 9 and 11. And R is the 10, 11, 14, 15. So 10 and 14 already selected by the P. So for the R, that is the 11 and 15. So for 8 and 9, we should choose only the Q. Okay. So Q is also the essential prime implicant to cover up the 8 and 9. From here also, we can see that. So from this table, we automatically define the P, Q and R, both are the, three are the essential prime implicant. Due to 2 and 6 are covered by only P, 8 and 9 are only cover up the only Q, and the 15 is only cover up by the R. So to cover up all the mean terms, we should take P, Q and R. Okay. So P, Q and R are the essential prime implicants for this example. Okay. So only you should observe in the prime implicant tables which are very much essential to cover up the mean terms.
Okay.
Please.
फोन नहीं कर सकता अभी।
Sorry,
क्लास
have any
चला।
doubt? Have you any doubt? Okay.
No, sir.
No, sir,
Okay.
no doubt.
Okay. So then we should go for the final table. So all are the prime implicants, P, Q and R. Now, if the P, Q are the prime implicant, essential prime implicants, then we will go for the simplified Boolean expression. So P is defined by this, Q is defined by this, and R is defined by this. So this is a sub expression. So we can write like this: P plus Q plus R. Okay. If I go for the next example, if there is a don't care is used, these are the mean terms 1, 2, 3, 9, 12, 13, 15, and considering 0, 7, 10, 15. This is very much interesting. Please go through this example minutely. I write the binary form of the mean terms first for your better understanding. So that is the 0 is 0 0 0 0, 1 is 0 0 0 1. So now from this we will make the group as index 0, index 1, index 2, index 3, index 4. No problem. Okay. Yeah. So now this is index 0 for 0, index 1 is 1 and 2, index 2 is 3, 9, 10, 12, index 3 is 7, 13 and 14, 3 ones are there, and this is the 4. Now this is the comparison, make the one another group. Suppose this is a index, suppose this is I 0, 1, now this is I 1, 2, suppose this is I 2, 3, clear, and suppose this is I 3, 4. Depending upon the 1 bit position change, put the dash here and make the group, no problem. So now here this is the 1, 9 is not compared with others, so put as a prime implicant. Okay, which mean terms are not used through comparison, then we should put as the prime implicant or select these mean terms at the prime implicant. So this is the first prime implicant, that is P. Now here this is 2, 10 is also not compared, then this is Q. 3, 7 is not compared, R. 9, 13 is not compared, S. 10, 14 is not compared, so T. Then again this is 7, 15 is not compared, so this is U. So now this is the total comparison of 0, 1, 2, 3. Clear? So 0, 1, 2, 3 is compared. Then we will get this 12, 13, 14, 15 is also compared. 12, 13, 14, 15. 14, 15 is compared for this. So then we will get this. So there is no comparison exists here. So we will make these as a prime implicants B and W. Okay. So we have here the prime implicants is P, Q, R, S, T, U, V and W. So there are so many prime implicants are there. For this reason I have chosen this example. So this is P, Q, R, S, T, U, V and W are the prime implicants. Put these prime implicants in the prime implicant table. Why are you sad with? Please go there. Please go there. Yeah. Prime implicant table. This is P, Q, R, S, T, U, V, W. So that is or I have written here P is means this, Q is means this from here. P is means this, P means dash 001, Q means dash 010. So we write here dash 001 dash 010. Similarly for R, S, T, U, B and W. Select this P for 1 and 9. So put here 1 and 9. Okay. So this is 1, this is 9. R, Q is 17 and 21. So put 17 and 21. Sorry. 17 Q 2 and 10. Sorry. Q is 2 and 10. So now this is Q is 2 and 10. 10 is the don't care. Please follow this prime implicants. We should not consider the don't care terms in the prime implicant table. This is very important. Okay. Only the mean terms are used in the soft expression. The mean terms are used in the prime implicants. We should not consider the don't care in the prime implicant table. So here the Q is only 2, R is 3, S is 9 and 13, T is 14, U is, there is only don't care, U is 7 and 15, 7 and 15 both are in don't care. So here we are not using it. So B for 1, 2 and 3, W is 12, 13 and 14. So from this we only get for 12 there is a single tick. So W is the essential prime implicant. Okay. For P, if we take P, then we will get 1, 2, 1 and 9. Okay. So now for W is the essential prime implicant. So most optimum expression would result, suppose if we take W, then we will cover the 12. Now if we take P, then 1 and 9. Clear? So now if we take P, then we will get 2, 2, 3 and P, already P is there. So P, V and W, then we will cover all the mean terms. Please see in the prime implicant table. If we take P, then we will get 1 and 9. If we take V, then we will get 2 and 3. Okay. And if we get W, W is the essential prime implicant for this single tick. So W should be covered. So then W 12, 13 and 14. So if we take P, V, W, then we cover all the mean terms. Another case, if we take instead of P, if we take S, V and W, S is 9 and 13. Okay. And V is 1, 2, 3. So then we will get 1, 2, 3 and 9. And if we take W, then 12, 13, 15. So if we take S, V and W, then all the mean terms will be covered. So there is two options. One is if we take P, V and W, then all the mean terms will be covered. Or if we take S, V and W, then all the mean terms will be covered. Okay. So there is two option of the minimization and we will get this from P, V and W. Please. P, V and W. So then we will get for P, we will get Yeah. For P, we will get B bar, C bar, D. Okay. So this is not properly written. Okay. Oh no, this is B bar, C bar, D. Okay. So B bar, C bar, D, and then V. V means dash dash. That is means sorry, A B. That is means A bar, B bar, 0 0. So that is A bar, B bar, A bar, B bar, and again W. W means 1 1. So that is AB. So AB plus A bar, B bar plus B bar, C bar, D. This is P. This is P. A bar, B bar. This is B. So this is B, and this is W. Okay. From this is S. S means this is A, C bar, D, A, C bar, D. So this is S, this is B, and this is W. So we can make this. If we go through the problems like this is the 5 variable, 27. So if we make this and comparison like this by using the 1 bit position change, then compare